Welcome to this section on creating your first serverless microservice. This section is one of the most interesting as it's heavily hands-on in terms of configuration in the AWS console, but also Python code. For the Python code, I have kept it simple so that you can understand it and easily modify it for your own use cases. In this section, we are going to take a look at first, the architecture of building a serverless microservice. Then we're going to talk about how you can set up a Lambda function in the AWS Management Console, and then setting up an API gateway that integrates with the Lambda proxy. And then we are going to look at creating a NoSQL database in DynamoDB, creating the table, inserting data, and then querying the data. Then we will look at creating a Lambda that is able to query that DynamoDB table. And finally, we're going to put everything together in one piece of code. In this video, we are going to look at building a serverless microservice data API. In this video, we are going to take a look at JSON file formats. This is the essential format used in all microservices and REST APIs. Then we're going to talk about the microservices data API requirements for the API itself. And then we're going to provide an example of the time series data that we're going to be storing against a specific user, and talk about the architecture finally in terms of the request data flow and the response data flow. First, JSON file formats. So JSON, or JavaScript Object Notation, is a standard format of data that is used in REST APIs and microservices. It is aimed to be read by humans, but also machines. So humans can actually understand the values, and also machines can automatically parse the data. The data objects consist of attribute value pairs and array data types. On the right, I have an example of John Smith, for example. You can see the first name is the key and the value is John. In that way, you have two strings separated by a colon. So you can see that John Smith is age 27 and the address where he lives is New York with the postal code 10021-3100. And you can see that he has two phone numbers. One phone number is at home and the other one is a mobile phone number. So JSON is very descriptive. Here I've shown it doesn't have to be flat. It can also be hierarchical, and it allows you to have the schema almost built into the data, which is not always the case in comma-separated variable files, for example. So you can very easily add new key pairs to JSON data. So in terms of the serverless microservice data API requirements, we want to create a microservice that is able to serve web visits counts for a specific user. The data that we have is basically a daily count for each specific user ID. And here, this is the request that we want to pass on. So we're going to be querying by user ID and start date, and we want to retrieve all the counts of web visits after the start date. So you can see that we have a user ID, in this case 123, and a start date parameter formatted in the year, month, day format. In this case, it's 2018-01-02. This is the request, so we can either enter this in the browser or programmatically enter this request. And the response that we want to get is from the NoSQL database where the data is stored, and the actual response format will be in JSON, coming back from the database through the Lambda and back to be presented back to either the user or the other machine that's queried the API. We also want this API to scale very easily and be very cost effective. We don't want to have a machine running on all the time, for example. That would cost money. We only want to pay almost when there are requests. So to give you a more precise example of the time series counting data that we're interested in, here we have an event ID, which is based on the user 324, for example, and we have the date in this format, the event day, which we've got in October 2017, and we have a count of events on the right in the table. So you can see that on the 10th of October 2017, user ID or event ID 324 had an event count of 2, which means there was a daily count of visits equal to 2 on that specific day. The next day that increased to 10, and then on the 13th that increased to 10, and then it went down to 6 and 6 and 2. So if we plot that in Excel, you would see this sort of chart on the right with the event counts beginning at 2, and then there was a gap on the 11th where there was no visits for this specific user, and then it increased to 10, 10, 6, 6, 2, again with a gap on the 15th. So this is what we want our API to provide, essentially. In terms of architecture, so the request will look like this. We have a client browser, a mobile client, or a backend service in the internet that will query our API gateway, passing the request with the user ID and the start date as an optional parameter. This will get authenticated through an AWS IAM role that will then launch the Lambda function. The Lambda function will then use a role to access DynamoDB and pass that query to Dynamo to query for that specific user and that specific date range. The data will come back on the bottom right from Dynamo back to the Lambda function in JSON format, and then that will get passed by the Lambda function back into the API gateway and eventually returned to the client browser, mobile client, or backend service that made the initial request. Again, the whole stack is serverless, and it relies on the JSON formats for data exchange between all the services.